video is about how to use density as a conversion factor. First, let's talk about what a conversion factor is. A conversion factor is a ratio, which is also written as a fraction, and it represents the relationship between two different units. For example, if I wanted to write a conversion factor for feet and inches, I could say that there are 12 inches that are in 1 foot. That would be a ratio, that is a relationship between those two different units. I could also write this as 1 foot is in 12 inches. It is the same relationship, the same two units that I'm trying, or the same units as earlier. Feet versus inches are two different units that I'm trying to compare. I just flipped how my conversion factor is set up. Density can also be used as a conversion factor. So density is defined as the ratio of mass to volume. So if I wanted to write this equation, I could say that density is equal to mass over volume. Well, this is how your units look for density. It could be in 2.27 grams per milliliter. We've also learned that we could have our units in grams per centimeters cubed. Little side note is that 1 centimeter cubed is equal to 1 milliliter. So it won't matter which unit we have for that last component, for that volume component. They're going to be equivalent. So if I have my 2.27 grams per milliliter, that is saying that I have 2.27 grams that will take up 1 milliliter of space. This grams per milliliter is this number of grams in reference to 1 milliliter. It's like saying I'm going 50 miles per hour. That would mean I'm going 50 miles for every 1 hour. Just as in our inches and our feet example, I don't have to leave it like this. I could also write it as 1 milliliter of whatever this substance contains, or whatever this substance is. 1 milliliter has a mass of 2.27 grams. These are the conversion factors. They are that fraction, they're that ratio, that is the relationship between our two different units. So let's see some examples and how we can use density as a conversion factor. When we need to use density will be when we're converting from mass into volume, or we're given a volume and we're converting into mass. That's when we're going to use density as a conversion factor. So my first example here, what mass of ethyl alcohol is needed to fill a 200 milliliter container? And then I have the density of alcohol is 0.789 grams per milliliter. Off to the side here, I've written kind of some steps. So step 1, my hints, is that we need to identify what is our fact, which is information about our object, and what is our factor, which is an abbreviation for our conversion factor. What is our relationship? What is that fraction that gets us to compare those two different units? So first, my fact, and then my factor. My fact is information that I know about my substance. So I've got what mass, well that's what I'm trying to find, is needed to fill a 200 milliliter container. This here is my fact. This other number, the density of ethyl alcohol, is 0.789. Well, because this has those two different units, my grams per milliliter, then this is my factor. I'm I'm going to always start with my fact. So over here under fact, I'm going to go ahead and write 200.0 milliliters. Now, my next step is to set up my factor so that the units on the fact cancel. So, again, my factor is that fraction form, that ratio form that relates my two different units. Right now, my fact is in units of volume or of milliliters, but I don't want it to stay in volume units. I am instead trying to figure out what mass. So my answer ultimately needs to be in grams. Well, in order to set up my factor, I need to cancel these milliliter units. Right now, they're on the top. We could easily write this over 1. It doesn't change my number because anything over 1 is the same. So right now, my milliliters is on the top. I want to cancel that, so I would put it on the bottom. Similar to any type of fraction, if I have like a 3 on top and a 3 on the bottom, that reduces down to 1. So they would cancel out. If I have like a 55 on the top and a 55 on the bottom, they're the same numbers, they reduce out to 1. They can simplify. That same idea is being used here with our units. We have a unit on the top, we have a unit on the bottom, the same unit on the bottom. They will ultimately cancel. Now, my factor is density, so I've got my milliliters. The other unit of my factor is my grams. So I'm going to put those on top. Just to double check, I've got milliliters on the top. That would cancel with milliliters on the bottom. And I would be left with grams. My grams won't cancel with anything. Well, that's good because I'm trying to find mass, and mass is measured in grams. My third step. After the units are in the correct spot, I want to fill in the numerical values for the factor. So remember how I wrote my factor up here as a fraction? And I had my 2.27 go with my grams on the top, and that was for every 1 milliliter? I need to do the same thing but with this number now. So I've got 0.789. I need to figure out whether that goes on top with my grams or whether that goes on bottom with my milliliters. Anytime your factor is written like this, then your numerical value goes with your first unit. So this is saying 0.789 grams. So I'm going to write that, 0.789 grams is in 1 milliliter, or for every 1 milliliter. Anytime it's this grams slash milliliters, it's grams per milliliter. We're looking at that being per 1 milliliter. We simplify it down to a 1 milliliter. All right, I've got my fact. I've got my factor, my units cancel, I've got my numerical value in the correct spot. Your last step is that any numbers that are on the top, you times or you multiply them. And any numbers that go down, you divide. So what does that mean? Well, if I consider this to be a fraction, again, you don't have to have that over 1, you can ignore it. And I'm actually I'm gonna ignore it. It's over 1, it doesn't change my number. So I'm going to look at 200 times, this number is on the top, so I'm going to go times 0.789. And then because my 1 is down in my denominator, I'm going to do divided by 1. Well, anything divided by 1 is going to be itself, so it's really not going to change our answer. So when I plug this into my calculator, I'm going to put in 200 times my 0.789 equals 157.8. There we go. Kind of hard to see with that glare. My apologies. So 157.8. And then the unit on that would be grams because my grams didn't cancel. try another example. Silver has a density of 10.5 grams per centimeter cubed. Here I've got grams per centimeter cubed. In my previous example, I had grams per milliliter, but keep in mind that 1 centimeter cubed is equivalent to 1 milliliter, so it will not matter what units I have. Perfect. What volume of silver metal would weigh 2,500.0 grams? All right, again, I'm going to start out with identifying, rule 1 over here was identifying my fact and my factor. So my fact is the information that I know about my object. My factor is whatever fraction or ratio I have that relates my two different units. Well, this first number, 10.5 grams per centimeter cubed, that has two different units in it. So automatically this is my factor because I can write that as a fraction that relates my two different units. This other number, my 2,500 grams, is my fact because it's information that I know about my object. So I'm going to start with my fact. Again, my factor is a fraction. That's why I've drawn this line to represent that I'm going to put my fraction in there. My second step, set up the factor so that the units on the fact cancel. Well, right now I've got grams, so I need to cancel those grams. I'm going to put them on the bottom. They're on the top right now, they're on the bottom over here, so those would cancel. My factor, the other component of my factor, has units of centimeters cubed. I'm going to put that on top because this is my factor. It has those units. I have to use those two units. Now, I'm trying to find volume. If my grams cancel out, would I be left with units of volume? Yep, because centimeters cubed also measures volume. So before I even plugged any numbers in, the most important part is to make sure that your units are set up so they cancel when they're supposed to, and that you're not canceling the ones that we still need. My step 3, after the units are in the correct spot, I fill in the numerical values for the factor. So I've got my 10.5 grams per centimeters cubed. Again, I need to figure out whether my 10.5 is going to go with my centimeters cubed or whether that 10.5 is going to go with my grams. Well, this can be written as 10.5 grams for every 1 centimeters cubed. So my 10.5 goes with my unit of grams. And that is for every 1 centimeter cubed. Now I've got my numbers in the right spot. I can go ahead and solve this. So again, any numbers on the top I times, and any numbers that go down I'm going to divide. So if I put in 2,500, let me scoot this up a little so you can see what I'm plugging in my calculator. 2,500 times any number that's on the top. Well, it's times 1, so that's not going to change my number. But then I've got this number that goes down. So I'm going to go 2,500 divided by 10.5 equals, it gives me a value of 238.09. Well, that's a lot of digits that my calculator is giving me. I have to figure out how many significant figures I should actually have in my number. So in this first fact, I had 1, 2, 3, 4, 5 significant digits. Over here in my density, I only had 1, 2, 3 significant digits. I'm multiplying and dividing, so I need to use my least number of sig figs, which is my 3. So I'm going to go 238 centimeters cubed as my answer. I hope that was helpful. I would like to thank www.chemteam.info/sigfig/density.html because that is where I pulled these practice problems from. Please let me know if you're having problems. One of the main issues, or one of the common errors that students make, is that they try to plug in numbers on either the top or bottom without looking at the units. Often they will flip the 1 and the 10.5, that location. You have to be mindful of how your units cancel, and you have to be mindful that your 10.5 will go with your grams for every 1 centimeter cubed. Hope that was helpful. Come see me if you need more practice or would like to ask me more questions. Bye!